Right, now we are going to start with another chapter of derivatives, which is logarithmic function. Now this is an extremely important chapter. You definitely get a sum in the paper from this chapter. Question: how do I identify this? How do I know that this is logarithmic function? Derivatives, log functions. Identify. How do I identify this? There are two cases how you have to identify this. First, if there are multiple arithmetic operators, or there is a variable in the exponent, or there is a variable in the indice. If you have one of these two conditions satisfied, then it is logarithmic function. If you have multiple arithmetic operators like multiplication, division, subtraction, addition, exponential, or if there is a variable in the indice, then it is supposed to be logarithmic function. How do I solve a logarithmic function? In order to solve a logarithmic function, you have to take log on both the sides. Please people, remember how to identify this. Once you are able to identify, then the solving part is very easy. I'll repeat this once again. If you have multiple arithmetic operators, or if you have variable in the indice, then it is said to be a logarithmic function. Fine. Let's see how do we solve this. We will leave this here for the timing. Y is equal to square root of 3 plus x upon 3 minus x into x square plus 5. Now if you look at this sum, you have multiple arithmetic operators here. There is a square root, division, multiplication, addition, subtraction. Since you have multiple arithmetic operator, it satisfies the first condition. How do you solve this? Take log on both sides. If I take log on both sides, I will get log y is log square root of 3 plus x, 3 minus x, x square plus 5. Right? Now, let's see this. In log, multiplication changes to addition, division changes to subtraction, and square root changes to indice 1 by 2. So this will be log 3 plus x raised to 1 by 2 minus log 3 minus x raised to 1 by 2 plus log x square plus 5. Right? So you get log y is equal to this. Now differentiate with respect to x. So d by dx of log y is d by dx of log 3 plus x raised to 1 by 2 log 3 minus x raised to 1 by 2 log x square plus 5. Right? Now this is the first time that you have a composite function on the left hand side also. This is x, this is y, that means I have to use composite function or chain rule. D by dx of log u is 1 upon u d by dx of u. Here I am assuming y to be u. So 1 upon y d by dx of y. Now whatever is the number in the indice comes before the log. So this will be 1 upon 2 log 3 plus x minus number in the indice comes before the log plus log x square plus 5. Okay, this is 1 upon y dy by dx is 1 upon 2 is constant. D by dx of log u is 1 upon u d by dx of u minus 1 upon 2 d by dx of log u is 1 upon u d by dx of u plus d by dx of log u is 1 upon u d by dx of u. Fine. Now take y on the other side, so I'll get dy by dx is equal to y. This is 1 upon 2 3 plus x. D by dx of 3 is 0. D by dx of x is 1, which can be written here as it is, minus 2 3 minus x. D by dx of 3 is 0. D by dx of x is 1. Since there is a minus sign here, this will be minus 1 plus x square plus 5. D by dx of x square is 2x. Fine, do we get this? Now we substitute the value of y. We had already taken the value of y. We had already taken the value of y to be this. Resubstitute this value of y in your final answer, which is here. You will resubstitute the value of y here. So you will get the answer as dy by dx is, instead of y I am writing square root of 3 plus x 3 minus x into x square plus 5, then into 1 upon 2 3 plus x minus into minus plus 1 upon 2 3 minus x plus 2x upon x square plus 5. That will be your answer for the sum. Fine. So do we understand how to do logarithmic type? Let's move on to the next sum, guys. So in this sum we had multiple arithmetic operators. Now let us see a sum where you have a variable in the index. Y is equal to 2x square minus 3 raised to 5 minus 3x. There is a variable in the indice here. There is a variable in the indice here, therefore it is a log function. How do I solve this? Take log on both sides. If I take log on both sides, I will get log y is log 2x square minus 3 raised to 5 minus 3x. So you will get log y is equal to, whatever is the number in the indice comes before log. So this will be 5 minus 3x log 2x square minus 3. Differentiate with respect to x. Dy dx of log y is 1 upon y dy by dx. Dy dx of 5 minus 3x log 2x square minus 3. Now since there are two terms here and there is multiplication of two terms, this is going to be uv formula. So you will have 1 upon y dy by dx uv formula. V multiplication formula, that is v derivative of u plus u derivative of v. Fine. Dy by dx, take the y on the other side. This is division here. When you take it on the other side, it will become multiplication. This is log 2x square minus 3. D by dx of 5 is 0. D by dx of minus 3x is minus 3 plus 5 minus 3x. D by dx of log u is 1 upon u d by dx of u 2x square minus 3. Fine. Resubstitute the value of y. You had taken this to be the value of y. Your original question was the value of y. So resubstitute the value of y. So you will get 2x square minus 3 raised to 5 minus 3x log 2x square minus 3. This minus 3 I can write first. So minus 3 log of this plus 5 minus 3x upon 2x square minus 3. 2 as it is. D by dx of x square is 4x minus 3. D by dx of 3 is 0. So So that will be your answer. Simple sum. Right? Let's move on to the next sum, guys. Y is equal to tan x raised to log x. Again, same thing. You have a variable in the indice. When you have a variable in the indice, it is log function. You have to take log on both sides. If I take log on both sides, I can say log y is nothing but log of tan x raised to log x. So you will get log y is log x log of tan x. Whatever is the number in the indice comes before log. Now differentiate with respect to x. So you will get d by dx of y log y, sorry, d by dx of log y is d by dx of log x into log of tan x. D by dx of log y is 1 upon y dy by dx. UV formula, multiplication formula, v derivative of u plus u derivative of v log tan x. Fine. Dy by dx, y is division on this side. When it goes on the other side, will become multiplication. This is log tan x. D by dx of log x is 1 upon x plus log x. D by dx of log u is 1 upon u d by dx of u. Right? Do we get this in here? Now, dy by dx, resubstitute the value of y. This, the original question is the value of y. Resubstitute this in your final answer. So this will be tan x raised to log x multiplied by log tan x upon x plus log x upon tan x. D by dx of tan x is nothing but sec square x. That will be your answer. Fine, do we get this? Let's see another sum, guys. Let's see if we can fit it here. Y is equal to log x raised to sin x. Log x raised to sin x. Fine. You have a variable in the indice, that means this is logarithmic time. Take log on both sides. If I take log, I'll get log y is log x raised to sin x. Log y is log x raised to sin x. Whatever is the number in the indice goes before the log. So you will get log y is sin x log of log x. Differentiate with respect to x. So you will get d by dx of log y is d by dx of sin x log of log x. Right? Now d by dx of log y is 1 upon y dy by dx. UV formula v derivative of u plus u derivative of v. Fine. Take y on the other side, so dy by dx is equal to y goes on the other side log of log x. D by dx of sin x is cos x plus sin x. Log u is 1 upon u d by dx of u. right? Y, this is y. Resubstitute the value of y, so you will get dy by dx is log x raised to sin x log of log x cos x plus sin x upon log x. D by dx of log x is 1 upon x, which I can write here, right? This will be your answer for the sum. Fine. Let's move on to the next sum. Y is equal to x raised to e raised to x. You definitely have a variable in the index, that means it's a log function. Take log on both sides. If I take log on both sides, I get log y is log of x raised to e raised to x, right? Now whatever is the number in the index goes before log, so you will get log y is e raised to x log x. Differentiate with respect to x, so you will get d by dx of log y is d by dx of e raised to x log x, right? D by dx of log y is 1 upon y dy by dx is equal to uv formula, v derivative of u plus u derivative of v. Take y on the other side, so you will get dy by dx is equal to y goes on the other side log x, d by dx of e raised to x is e raised to x plus e raised to x, d by dx of log x is 1 upon x. Resubstitute the value of y. Your question is y. Y is x raised to e raised to x. Resubstitute that here. So you will get dy by dx is x raised to e raised to x. I could take, between these two terms, I could take e raised to x common. So you will get log x plus 1 upon x. That will be your answer. Fine. Let's see another sum, guys. Y is x raised to x raised to x. There's a variable in the index. Take log on both sides. If I take log on both sides, I'll get log y is log of x raised to x raised to x. So I'll get log y is x raised to x log x, right? Call this as equation 1 and leave this here. Now let u be equal to x raised to x. There is still a variable in the index, so I will solve this term separately first. Since there is a variable in the index, I will take log on both sides. So I will get log u is log of x raised to x. So you will get log u is x log x. Fine. Now differentiate log u. Differentiate with respect to x. So log u will be 1 upon u d by dx of u is equal to, here uv formula, v derivative of u plus u derivative of v. Take u on the other side. D by dx of u is u log x. D by dx of x is 1 plus x. D by dx of log x is 1 upon x. Resubstitute the value of u. The value of u is x raised to x. the value of u is x raised to x. So you will get dy dx of x raised to x is x raised to x log x plus 1, right? Call this as equation 2. Now let's start with equation 1. From equation 1 I could say that log y is x raised to x log x, right? We'll continue this sum on this side, right hand side, log x. Now I'll say differentiate with respect to x. That means I'll say dy dx of log y is dy dx of x raised to x log x, right? Dy dx of log y is 1 upon y dy by dx, right? Here again you will use uv formula. This is v derivative of u plus u derivative of v, right? Take y on the other side, so you will get dy by dx is equal to y log x into d by dx of x raised to x. This you can substitute from equation 2. This d by dx of x raised to x you can substitute from equation 2. In equation 2 you had found out that d by dx of x raised to x is x raised to x log x plus 1. So this is going to be x raised to x 1 plus log x plus x raised to x. Dy dx of log x is 1 upon x. We substitute dy dx of y, substitute the value of y. The value of y is the original sum. So value of y is x raised to x raised to x, x raised to x raised to x. Now between these two terms I can take x raised to x common. So I'll get log x 1 plus log x plus 1. That will be your final answer for this sum, right? Good sum. Let's move on ahead, people. Now so far you just had variable in the indice, single term. What if you get this in terms of algebraic equations, right? If I get this in terms of algebraic equation, suppose if I had y is equal to 7 raised to sin x plus sin x raised to x, right? I have a variable in the indice. Since I have a variable in the indice, that means this is going to be logarithmic function. But there is an addition sign in between. I cannot use log with an addition sign in between. So what I am going to do is, I will say let u be equal to 7 raised to sin x, right? Differentiate with respect to x. So d by dx of u, you can use the formula a raised to u, d by dx of 7 raised to sin x. So d by dx of u, a raised to u is a raised to u log a d by dx of u. So you will get du by dx is 7 raised to sin x log 7. D by dx of sin x is cos x. Now let the second term be equal to v. So you will say let v be equal to sin x raised to x. There is a variable in the indice, so take log on both sides. If I take log on both sides, I will get log v is nothing but log of sin x raised to x. Log v is x log of sin x. Whatever is the term in the indice comes before the log, right? Now differentiate with respect to x. differentiate with respect to x. So d by dx of log v is 1 upon v dv by dx. Here I'm going to use the uv formula. So v derivative of u plus u derivative of v. Right? Take v on the other side. dv by dx is equal to v goes on the other side log sin x. d by dx of x is 1 plus x log u is 1 upon u d by dx of u. Right? We substitute the value of v. The value of v is going to be sin x raised to x. Sin x raised to x log sin x plus x upon sin x. d by dx of sin x is cos x. Right? Now call this as equation 2. The dv by dx call it as equation 2. The du by dx that you had found out, call that as equation 1. Okay. Now, if I look at my value of u and v, and if I look at my original sum, I can say but y is equal to u plus v. 7 raised to sin x is u, sin x raised to x is v. Hence, I can say that y is equal to u plus v. Differentiate this equation. So you will get d by dx of y is d by dx of u plus d by dx of v. Substitute the values, so you will get dy by dx from equation 1. From equation 1, I can get the value of du by dx. So du by dx I am going to substitute from equation 1. 7 raised to sin x log 7 cos x plus dv by dx I can get from equation 2. So my equation 2 says sin x raised to x log sin x plus x cos x upon sin x can be written as cot x. This is going to be your final answer. Fine, do we get this thing here? So whenever you have a mathematical operation like addition or subtraction with a variable in the indice, this is how you have to solve this. I'll show you another sum of this kind, guys. Y is equal to x raised to root x plus root x raised to x. You have a variable in the indice through and through. You will say let u be equal to x raised to root x. Since there is a variable in the indice, you will say take log on both sides. If I take log on both sides, I will get log u is log of x raised to root x, right? So you could say log u is root x log x. Take the root x on whatever the number in the indice comes before the log. Differentiate with respect to x. So this will become 1 upon u d by dx of u. Here you will be using uv formula. So v derivative of u plus u derivative of v. Right? Take u on the other side, so you will get du by dx is equal to u log x. d by dx of root x is 1 upon 2 root x plus root x. d by dx of log x is 1 upon x. So you will get du by dx. U is nothing but x raised to root x. U is nothing but x raised to root x, right? This can be written as log x upon 2 root x plus this and this cancels to give you 1 upon root x. Fine. I could take root x common, so you will get du by dx is x raised to root x, 1 upon root x common. This is log x upon 2 plus 1, right? Now, this can be written as du by dx is x raised to root x upon root x log x plus 2 upon 2. Leave that there as it is. Call this as equation 1. Now, the second term that you have, you will assume that to be v. So you will say let v be equal to root x raised to x. Take log on both sides. If I take log on both sides, I'll get log v is log of root x raised to x. So you will get log v is x log root x. Whatever is the number in the index comes before the log. Differentiate with respect to x. So this will be 1 upon v d by dx of v. Here you will use the uv formula. So this is v derivative of u plus u derivative of v. Right? Take v on the other side, so you will get dv by dx is equal to v log root x. D by dx of x is 1 plus x. D by dx of log u is nothing but 1 upon u d by dx of u. Resubstitute the value. The value of v is nothing but root x raised to x log root x plus this and this cancels to give you root x. D by dx of root x is 1 upon 2 root x. Root x further gets cancelled. So you will have root x raised to x log root x plus 1 upon 2. Call this as equation 2. So you have equation 1, equation 2. The original sum. I'm going to continue the sum here. I can say, but y, this is u, this is v. But y is equal to u plus v. Right? Differentiate with respect to x. So you will get d by dx of y is d by dx of u plus d by dx of v. Right? You have the value of d by dx of u and d by dx of v from equation 1 and equation 2. Therefore, you could say that dy by dx, du by dx I can get from equation 1, which is nothing but x raised to root x upon root x log x plus 2 upon 2 plus dv by dx I can get from equation 2, which is nothing but root x raised to x log root x plus 1 by 2. That will be the answer for your sum. Right? Let's move on to the next sum, guys. Y is equal to cos x raised to log x plus log x raised to x. Same thing, let u be equal to cos x raised to log x. Since there is a variable in the indice, take log on both sides. If I take log on both sides, I will get log u is nothing but log of cos x raised to log x. Whatever is the number in the indice comes before log, so you will get log u is nothing but log x into log of cos x. Differentiate with respect to x. Log u is 1 upon u d by dx of u. Multiplication, uv formula. V derivative of u plus u derivative of v. Right? Take u on the other side. So you will get d by dx of u is equal to, u is division, goes on the other side, becomes multiplication. This is going to be log cos x. D by dx of log x is 1 upon x. Log x. D by dx of log u is 1 upon u d by dx of u. Right? U can be written as, we have assumed u to be cos x raised to log x. So this is cos x raised to log x, log cos x upon x plus log x upon cos x, d by dx of cos x minus sin x. Call this as equation 1. Same way, the other term to be equation 2, that is, let it be equal to v. V is log x raised to x. Since there is a variable in the indice, you will take log on both sides. On both sides. Right? So you will get log v is log of x raised to x. Whatever is the number in the indice comes before the log. So in that case you will get log v is x log of x. I'm sure half of you are yawning by this time. Right? So now this can be written as differentiate with respect to x. Log v 1 upon v d by dx of v. uv formula. This is v derivative of u plus u derivative of v. Right? So you will get dv by dx. V is division here, when it goes on the other side becomes multiplication. Log of log x, d by dx of x is 1 plus x. Log u is 1 upon u d by dx of u. Right? Resubstitute the value of v. The value of v is log x raised to x. Log x raised to x. Log of log x plus x upon log x. D by dx of log x is 1 upon x. Cancel, cancel. Right? This is going to be your equation 2. Right? Once you have this, y, you have assumed this to be u, you have assumed this to be v. So you can say, but y is equal to u plus v. Differentiate with respect to x. So you will get d by dx of y is d by dx of u plus d by dx of v. Therefore, you can say that d by dx of y is d by dx of u, you will get from first equation. D by dx of u, you will get from the first equation, which is nothing but cos x raised to log x into log cos x upon x plus, now see this, Plus into minus is minus. Sin upon cos can be written as tan x log x, right? Plus dy dx of v, which we found out from here, from equation number 2, which is log x raised to x log of log x plus 1, right? So that will be your answer for this sum. The last sum for this chapter is y is equal to cos x raised to x upon 1 plus x square, right? There's a variable in the indice, that means you will take log on both sides. Take log, so you will get log y is log of cos x raised to x upon 1 plus x square, right? This can be written as division changes to subtraction and the number in the indice goes before the log. So this will be x log cos x minus log of 1 plus x square. Division changes to subtraction, the number in the indice goes before the log, right? Differentiate with respect to x. So you will get dy dx of log y is 1 upon y, dy dx of y. Here you will apply the uv formula. This is v derivative of u plus u derivative of v, right? Minus log u 1 upon u dy dx of u. So you will get dy dx of y is division y goes on the other side, becomes multiplication, log cos x plus x, dy dx of log u is 1 upon u dy dx of u minus 1 plus x square, dy dx of 1 is 0, dy dx of x square is 2x, right? Now the y is going to be for both the terms, okay? So you will get dy by dx is resubstitute the value of y. Your question is the value of y. So that is cos x raised to x upon 1 plus x square. This is log cos x plus x. Dy dx of cos x is minus sin x. That minus sign multiplies with this addition to give you minus. Dy dx of cos x is minus sin x. So sin upon cos is going to give you tan x minus 2x upon 1 plus x square. That is going to be your answer for this sum. This finishes your chapter. Thank you.